This is Honors Geometry Lesson 12.1, Exploring Solids. We're going to start our final unit of Honors Geometry, which is solids. So the first thing I'd like to talk about is the vocabulary. So the first thing we talk about is a polyhedron, and that's a solid bound by polygons. So be careful, the segments have to be straight, no curved surfaces. A circle's not a polygon. And it encloses a single region of space. So in other words, it has to be a closed figure. The edges are the line segments, the vertex are the points, and we can say a plural for polyhedron. We can say polyhedra, or we can just say polyhedrons. So again, an edge would be this line segment, the vertex or the corners maybe, and each of the sides are what we call the face. If it's a prism, the sides are going to be rectangles or parallelograms. And we name the prism by its base, and in order to be a base, it has to be two congruent polygons in parallel planes. For the first one you're seeing here, it's a rectangular prism. You can call any side the base. Most people think of the base as the bottom, but they're not necessarily going to draw the base on the bottom. Sometimes they'll knock it over so you can see the base better. The hardest part of doing volume calculations really is reading the diagram. So I just want to make sure you're comfortable reading the diagram. You can see this one is a rectangular prism. The sides are rectangles and the base is a rectangle. This one's a pyramid, and a pyramid, the sides are triangles, and the base in this case is a square. So we would call this a square pyramid. If it has a curved surface, then we don't consider it a polyhedron. So a sphere, a cylinder, and a cone are not considered polyhedron. A cylinder is going to have a circular base, and if those two circular bases are perpendicular, then we call that a right cylinder. If it's sort of tilted over, say you had a stack of quarters and they start to fall over, we call that an oblique cylinder. And the last thing I want to talk about is concave versus convex. If you can connect any 2 points on your polyhedron and the line falls all outside of your polyhedron, then we call that a concave. You can see this one is concave. If you connect any 2 points and the segment connects inside, then we call that a convex polyhedron. Okay, so let's go ahead and practice a couple. Again, we first decide, is it a polyhedron? Is it closed? And does it have any curved surfaces? This one's closed. It has no curved surfaces, so we can consider this on a polyhedron. Now that we know it's a polyhedron, we name it by its base. You can see this one has a pentagon as its base, and its sides are triangles, so we know it's a pyramid. So we would call this one a pentagonal pyramid. This one again has a closed space, and the sides are all polygons, so we can consider this on a polyhedron. The bases are the congruent polygons in parallel planes, so you can see this one has a hexagon as its base. Its sides are rectangles or parallelograms, so we would call this one a hexagonal prism. The last one has a curved surface, and we're not allowed to have a curved surface in a polyhedron, so we would say this one is not a polyhedron. While we're doing vocabulary, I thought I'd go ahead and throw the sphere in there. A sphere is a set of all points in space, equidistant from the given point. The given point is called your center. So we had a circle, which was a set of all points on a plane, so it was two-dimensional. Now we're going to go three-dimensional and call it a sphere. It still has its radius, it still has chords, and if that chord goes through the center, then we call it the diameter. Okay? If you slice that orange right through the middle and look at it, that's what we call the great circle. So the great circle is right through the diameter. Okay, that's a quick review of the vocabulary. Please try the practice problems. Let me know if you have any questions, and I'll be happy to help. Have a good day. Thanks.